This is a lecture from Open Tuition. For the free lecture notes that go with this podcast, please visit opentuition.com. Several things today. First of all, inventory control, stock control, where several different things can be mentioned. So although this should be reasonably quick, let's make sure we sort them all out. I'm going for Irina. So, four separate things here. First of all, pure inventory control. XPLC needs to purchase 1,800 units a year. The purchase price of each unit, delivery cost per order, stock holding costs. It says calculate the optimum order quantity. Without repeating everything I went through last time, remember our job is to decide how many to order each time. We want 1,800 a year. Maybe we'll order 100 each time, 18 times. Or maybe we'll order 200 each time, 9 times a year, and so on. You remember? Our job is the optimum order quantity is whichever gives the minimum cost. And for this, has everybody got their formula sheets from yesterday? Fortunately, in the exam, it's stapled to everything else. But the first bit of this, the optimum order quantity, is simply using the formula, remembering what the symbols are. The economic or the optimal order quantity the square root of 2COD over CH. And apart from being able to use your calculator, it's very much just remembering what the symbols mean and being careful. Just to remind you, CO is the order cost each time. What is it from my example, please? Hello? In my example, what's the order cost each time? No. How much does it cost each time we place an order?
Delivery cost.
Yeah, I want a number. Every time we place an order, here we've got delivery costs of 32, and so the order cost each time, CO, 32. Everybody? D, remember, is the total demand per year. What is it for my example, please? What's the total demand per year? Thank you, Inessa. Well, the rest of you doing, it's on the first line, 1,800. Be careful there, what they often do, and it's such an obvious trick, but it's so obvious, it's so easy to miss it. They often tell you something like the demand per month, or the demand per quarter. And you know, if I'd said demand per month is 100, I hope obviously it's 1,200 a year. But it's when you're going fast, it's so easy to miss it. Yep. Christina? So just be careful. Finally, CH. Remember, is the cost of holding 1 unit for 1 year. Most times they actually give you the figure. They say something like the cost of holding 1 unit in inventory for 1 year is 10 cents or something. You've got the figure automatically. Otherwise they do what's here. I've said, I'm sorry, I've used the word stock, I should have used the word inventory, I'm sorry, but inventory holding costs per year, I've said 18% of purchase cost. So here, the purchase price is $25, 18%. 1 unit is 25, the cost of holding, 18% of 25. Am I right, $4.50? And again, forgive me, but read carefully. Occasionally they tell you, oh, it costs 10 cents a month or something. Well, if it's 10 cents a month, I hope clearly it's $1.20 a year. Alright? However, apart from learning what the symbols mean, it is simply sticking it in the formula. So check me. The square root of 2 times 32 times the demand 1800 divided by CH $4.50, which gives me Has anyone checked me? Oh, I've no room up there. But I get 160 units. Are we all happy? You are bound to get a few of those. And again, as long as you read carefully and remember the symbols and can use your calculator, they really should be easy marks. But, come on, are we all clear there? If you haven't got a square root button, I said before, you must have one for the exam. You must. Anyway. Very often all they want is the economic order quantity, but here I've also said what are the total costs per year for that order quantity. And so make sure you can do your costings. The total cost per year, remember we've 2 costs involved. Doesn't matter which order, but the total order cost, I'll write it in words, but obviously in the exam it's just got to be fast. Over a year, it's the number of orders times the cost each time. Sorry, you're trying to read my writing? I'll say what I've written again. It's number of orders times the cost each time. Since we are ordering 200 units each time, how many orders will there be, please? 9. It's 1,800 units a year, 200 each time. There are 9 orders. What's the cost each time we place an order? How much does it cost us every time we place an order? 32. Every time we place an order is 32. We're placing 9 orders a year. So over a year, the total cost... No wonder some of you were staring at me. Yes. Oh, I thought I'd woken up since yesterday. I'm sorry. Those of you who copied it, hit yourself, you're as daft as me. We're not ordering 200 each time, we're ordering 160 each time. I'm sorry. And so, how many orders will we need? If it's 1,800 a year, and it's 160 each time, is it 11.25? I do apologise. And I said before, don't round it. Although we can't place a quarter of an order, in the long term, some years you'll place 11 orders, some years you'll place 12. On average, it'll be 11.25. So I am sorry, are we all clear there? It's $32 each time, so the total cost... Is it $360? Thank you. The other cost... And again, be careful in the exam. They might want the total, or they might simply ask you for one of these two. But the other cost involved is the holding cost. And again, in words, the total cost over a year of holding inventory is your average inventory times the holding cost per unit. If we're ordering 160 each time, what will be the average inventory level, please? We're ordering 160 units each time. 160 arrives from the supplier. We sell them and it drops to 0. Then another 160 arrive. And yes, our inventory levels keep going between 160 units and 0. The average inventory is always half the order quantity, so 80 units. How much does it cost to hold each unit for a year? We worked out earlier, it was $4.50, wasn't it? And so over a year, 80 units on average at $4.50 each is $3.60. The total cost, $7.20 per annum. And I said I can't repeat the whole lecture, and in fact, all the talk round it is unlikely to be relevant in the exam. But remember, if we ordered any other quantity, if we were to order 100 each time, your average inventory would be lower, that cost would be lower. But if you ordered 100 each time, you'd need more orders, and so that cost would be higher. The formula is giving you the order quantity at which the total cost is a minimum. Alright? Now some of you are staring at that as though you've never seen anything like that in your life before. Are we all sort of vaguely happy about what we've done there? Sticking the figures in the formula, doing the costing. Because I say again, whatever else they ask or don't ask, there have to be several of those. Okay? Alright, so that's one aspect of it. Shortly you can try some. Are we all clear there? Alright, can we move on to B, which is completely different. YPLC has a minimum demand of 20 units a day, an average demand of 30 units a day, and a maximum demand of 40 units a day. So the demand per day is anything between 20 and 40. The lead time varies between 10 and 15. Anybody, what do we mean by the lead time? Oh, we are all asleep today. It's not so long ago. Alright, the lead time is the time between placing an order with the supplier and receiving the goods. Because obviously in real life, you might order whatever we had before, 160 units each time. But in real life, they're unlikely to arrive instantly. Place the order, and perhaps it's a week before you get your delivery. Alright? Well, that time period is the lead time. And what is it here? It says it varies between 10 and 15 days. And so if you remember, our problem is, if we know it's going to take 10, 15 days, whatever, before we get the order in, we need to place an order before we run out of inventory. Agreed? You've got to make sure you've still got units left so that we can carry on supplying customers while we're waiting for the new order to arrive. And so what we need to calculate here is the reorder level, and be very careful here. The reorder quantity is what we were doing in B. In A. The reorder quantity is the number we're ordering each time. But the reorder level is how many we need left in inventory when we place a new order? Everybody? Well, here it says for part 1, what must the reorder level be? Well, learn a rule, but at the same time see the logic. There's less to learn. Surely if you want to be certain of never running out of inventory, you've got to make sure you've enough left for the maximum possible you'll need, if you understand me. And so, the number you need left, the lead time, the worst that can happen, the maximum lead time is 15 days. So if you want to be sure of never running out, you need enough inventory to last you 15 days. What's the most I could need to sell each day? Well, the maximum demand is what? It's 40 per day. And if I want to be absolutely certain of not running out of inventory, I need to have enough left to be able to sell 40 a day for 15 days. I'll say you can learn a rule, but if you see the logic, there's not really much learning. Does that make sense, everybody? And therefore, if we're never going to run out of inventory, we need to reorder when we've 600 units in inventory. We all happy there? Alright, well, again, there's going to be one of these somewhere. It could be simply what's the reorder level, in which case we've finished. But if we carry on here to number 2, it says if the reorder quantity is 1200 units, so that's the number we're ordering each time. Well, for the same question, it says what's the maximum stock level or inventory level? And here again, please, although you can learn a rule, see the logic. If I say it too fast, stop me. But it's really two things. The first one is we're reordering when we're 600 units in inventory. There will be times when the lead time is 15 days and we're selling 40 units. There will be times when it drops to 0 when the new order arrives. But equally, there'll be other times when you don't need all 600 units because the delivery arrives faster or the demand per day is lower. You agree? And if you don't need all 600, if for instance, if you only needed 200 or something, then of course you'd still have some left when the new delivery arrives. And so, to see what the most that'll be left is, work out the minimum possible demand over lead time. And here I shouldn't actually need to write down the words. Tell me, what's the minimum I could possibly need to supply customers over the lead time? 20 per day, but in total, what's the minimum I could need?
200.
Yes. Surely the minimum we could possibly need is the minimum lead time. There will be occasions when the order arrives in 10 days. And the minimum we'd ever need to supply each day, the minimum demand, is 20 units. And therefore, whatever happens, I'm going to need at least 200 units. You would agree? And therefore, remember, we're reordering when we've 600 units left to make sure, if the worst happens, we're okay. If we don't need 600, on occasions there will be some left. Well, the maximum that's left when the new order arrives, or when the delivery arrives, remember, you placed the order when you'd 600 left. The minimum you'd ever need, we've just worked out, is 200 units. And therefore, the worst that can happen is you've still 400 units left when the new delivery arrives. There's one step left, but again, there's no point doing it unless it makes sense. There'll be times when you need all 600 and you've none left. There'll be times when you need less than 600 and you've still some left. Well, the most that could ever be left, do we agree, is 400. Christina? Finally, though, to answer the question, it says, what's the maximum inventory level? Well, it's not 400, because remember, that's the worst that can happen. That by the time the new order arrives, you've already got 400 left in inventory. The new order arrives, though, and how many do we receive? The reorder quantity was 1,200. And surely, therefore, if the new order arrives and you've still got 400 left, your inventory level would go to 1,600. There is the maximum inventory level. All right? So again, well, I could, but I'm not going to repeat everything I said. If that makes sense, great. Arithmetically, it's easy. If I said anything too fast, think about it, ask me. But I say again, if you've got the logic of it, then it's not really too much a question of learning. It's just being careful. And obviously be careful about two things sound similar. Reorder quantity, the amount you're receiving each time. Reorder level, the number left when you actually place the order. Okay? Alright. Well, again, there's almost certainly going to be one, maybe two of those. The third thing, C, something again separate. Something I didn't mention last time, but... Sorry, you alright, Liga? But I hope you'll find pretty easy. A company has... Now, that's my typing, I'm sorry, not physical. It should say physical. They have physical inventory of 20,000 units. And all we mean by physical inventory, I've been to my stores, I've counted, there are 20,000 units sitting there. Alright? If you jump a bit, the question says, what's the free inventory? And what we mean, well, I'll write down, physical inventory is the actual number in inventory. But what we mean by free inventory if you come to me with an order and you say, oh, I want 20,000 units or something, free inventory is the amount I'm capable of promising. the number we're able to promise to customers. And so look back to the question. We've got physical inventory of 20,000. There are 20,000 actually sat there. Why can't I simply promise 20,000 to my customer? Well, one reason is, if you look at the last bit of the second sentence, orders from customers for 14,000 are outstanding. So although I've got 20,000 inventory, 14,000 have already been promised to other people. Would you agree? There's only 6,000 left that I could sell to somebody else. However, we have another order placed with suppliers. There are some more arriving. And so I am going to be able to supply more. So what we're getting at is this. The physical is what? 20,000? I do know there's another order arriving. So, coming from suppliers, there's another how many? 10,000 coming? However, some are already promised to customers. How many is it? 6,000? No, 14,000, I'm sorry. And therefore, how many am I going to be able to supply? I'm going to have 30, 14 are promised. Is it 16,000? That is the free inventory. All right? Now, does that make sense, everybody? Laura?
It's okay.
Oh, no.
Because I thought that it is 6,000 because I don't have these 10,000.
No, but think about it. It's very... I mean, I have to effectively do this. People order books from me. And I might have 5 on my shelf, but I have to check, is somebody waiting for those 5? Because if they are, I can't promise one to you. But equally, if I've none on the shelf, if I know I've already ordered 5, they're not here yet, but they'll be here this week, sort of thing, then I can promise you a book. You understand me? But if I've none on my shelf, and I've not ordered any, I have to tell you I haven't got a book. You know, I'll place a new order, but it will take a while. Do you understand me? But it's very... You know, I often get people ordering a book, and I've none. But I placed an order last week for 5 books. I know it'll arrive soon. So if you order, I can say, yes, I can supply the book. It'll be later this week, you know, when my delivery arrives. You see my point? All right? Everybody. Because again, once you see the point, it's easy. It's a shame if you just have to learn a rule. You know, you've enough to learn without adding learning bits like that. Okay? All right, finally, just terminology here. They might mention somewhere the word buffer or safety stock or inventory, I am sorry. All this means, when we did example B for that maximum minimum demand, I'm not going to repeat it, I said, that all I hope made sense. The problem in real life, of course, is that it's usually impossible to predict maximum demand over lead time and maximum demand and so on, yeah? And so what tends to happen is you base your reorder level on sort of what on average you expect, but to be safe, you carry more inventory than you normally expect you'll need. Alright? You know, you expect you're going to need 50 or something. To be extra safe, in the case things go wrong, perhaps have an extra 10 on top. That's all buffer as safety inventory is. It's simply where you hold extra inventory. To be safe, or if you prefer, for unexpected level of demand. Alright? So if I always keep an extra 10 books just in case, you know, on average I'm not going to need them, but to be safe I hold an extra 10. The extra 10 is the buffer or the safety.